So on these two problems, we need to do exactly like the two that were at the top on your homework. We're going to write down all of the congruent corresponding sides, all of the congruent corresponding angles, and then we're going to write a triangle congruence statement. So my congruent corresponding sides, I'm going to start us off with a side, and I want you to tell me which one is congruent to it. So side HG, that is this side over here on the left. It has one congruence mark on it. Staying inside problem number 1, that would be congruent to what other side in that figure? JI. Because it also has one congruence mark on it. What about side GJ? It's congruent to, I'm sorry, which one? HI or IH. And then this last one's a little bit weird, so I'm going to trace around what we're looking at here. So we have this triangle, HGJ. And then we have the triangle that's on the upper side there, triangle IHJ. And if you notice, these two triangles share a side. They share this side right here. It's part of both triangles, so I have to include that in my triangle congruences as I'm talking about corresponding parts. This side is congruent to itself. It is the same size as itself. So I have HJ is congruent to HJ. Or you can flip the letters around if you want to. You can do HJ is congruent to JH. Whatever makes the most sense to you. Then we need our congruent corresponding angles. I'm going to start off with the easy one, and I want you guys to tell me which one is congruent to that. We're going to start with angle G. Which angle in the red outlined triangle is congruent to angle G? Angle I. For these next couple angles, I can't just name them with one letter. Because if I say angle H, am I talking about this angle? Or am I talking about this angle up here inside the red triangle? So instead of saying angle H, I need to give it a 3-letter name. So I'm going to say angle GHJ. Notice it has the H right in the middle so that I know that's my vertex. I'm talking about this angle right here. That would be congruent to what in the red triangle? IJH. This has J right in the middle, so I know that's the vertex. That would be this angle right here. And I have to use 3 letters again so that I know whether it's placing it inside the blue triangle or the red triangle. All right, so my last pair of congruent corresponding angles, I would have angle HJG. So angle HJG would be this angle right here inside the blue triangle. What is that congruent to in the red triangle? What has the same number of congruence marks as HJG, this angle right here? JHI, yes. Angle JHI. Now that we have all of our corresponding sides and corresponding angles written down, we can write our triangle congruence statement. So I'm going to write the first triangle. I'm going to say triangle HGJ is congruent to this second triangle. Because I've already written the first one, the order of the letters here has to be very specific. How would I write the second triangle name so that it is showing me my corresponding sides and angles with HGJ? JIH. Absolutely correct. Notice angle G is congruent to angle I. G is the middle letter. I is the middle letter here. Side HG is congruent to side JI. First two letters, first two letters. GJ is congruent to IH. Second two letters, second two letters. Same thing that we wrote with our congruences up here. The order of those pieces should be matching up so that you're showing all of your congruences. Number 2, these triangles aren't touching at all, so I'm going to be able to name all of the angles with just one letter. I don't have to worry about 3-letter names. Let's do our corresponding sides first. Congruent, corresponding sides. Give me one pair of sides that is congruent. UV and XY. Side UV is congruent to side XY. UV has 3 congruence marks on it. XY has 3 congruence marks on it. Give me another pair of corresponding congruent sides. YZ and VW. YZ has 1 congruence mark on it. VW has 1 congruence mark on it. And what would be my last pair of corresponding congruent sides? UW and XZ. UW is congruent to XZ. 1 congruence mark, sorry, 2 congruence marks in that spot on both triangles. All right, congruent corresponding angles. Give me a pair of angles that's congruent. U and X. Angle U is congruent to angle X. What's another pair of congruent corresponding angles? W and Z. Angle W is congruent to angle Z. And what would our last pair be? Y and V. All right, we've got all of our corresponding parts matched up. So our triangle congruence statement. Remember, the triangle congruence statement should be matching up all of my corresponding angles and all of my corresponding sides based on their position. So if I did triangle UWV is congruent to, what would this second triangle need to be named, or how exactly would it need to be named to be congruent with UWV? XZY. Wonderful work. Guys, I cannot possibly stress enough how important it is to be practicing with these triangle congruent statements, both how to read them and mark up your triangles, and how to write them, matching up your corresponding sides and angles, and how to write a triangle congruent statement. For the most part, we had a really good test on Module 4. Module 5, talking about triangles. If you're not practicing these things, it's going to be incredibly difficult to do well on this test. If you know how to make sense of your triangle congruent statements and you continue to practice along with us, doing your homework and doing the work with us, it will be much easier to be successful on this test. But this is not one where you can just kind of watch and soak it in and expect to do well. You're going to have to practice with this. All right, homework and warm-up can go in the tray, and then we're going to dig into your book first for our notes today. Yes, not on Canvas, but on McGraw-Hill, which there's a link to McGraw-Hill on Canvas. Okay. And you can click on that, yes. Yep. We're going to be on page 298 today, which is the page that we've been working on for the last 2 days when we were doing example problems. There's one more problem down at the bottom of the page. That's what I want to start with. There is a check problem down at the very bottom. First thing I notice in this check problem is that it gives me a triangle congruence statement. I want you guys to take about a minute and use that triangle congruence statement to completely mark up these two triangles here. Mark up the congruent angles, mark up the corresponding congruent sides. All right. Which sides are congruent according to our triangle congruence statement?
A, B, D, E.
A, B, and D, E?
Yeah, A, B, D, E.
What else?
A, C, and D, C.
A, C, and D, C, this one here?
Yeah.
I don't think so. A, C, and C, E. Let's look at the triangle congruent statement and see how we would know that. A is the first letter here, and C is the last letter. So when I'm finding the side that it's congruent to in the other triangle, I need the first letter, and I need the last letter. So that's how I know it's AC and EC. Please remember, and I know it's going to take some time to get used to, you're not matching them up just based on looks. You have to use that triangle congruence statement to make sure that you are matching pieces up correctly. What else is congruent sidewise? What other sides are congruent? DC and BC. All right, talk to me about angles. What angles are congruent? Angle A and angle E, they both have these right angle markings on them, but I also know from my congruent statement because A is first and E is first. What else is congruent? Angle D and angle B. How big is angle D? 38 degrees. So how big is angle B? 38 degrees. I'm going to go ahead and add that to my picture since I know that they are corresponding congruent parts. And then last but not least, angle C is congruent to angle C. So I got to look at this because I got 4 angle C's. I've got this one right here, this one here, this one here, and this one here. So I'm going to have to give them 3-letter names as I'm thinking about this. I want to make sure that we're familiar again with how to write an angle name that has 3 letters. So if I'm going to write an angle where C is my vertex, for the top triangle, we could call that angle BCA or ACB. Angle BCA. That tells me to start at B, come down here to C, and then go up to A. So angle BCA, that's where that letter Y is. And that corresponds to what 3-letter named angle in the bottom triangle? DCE. Absolutely correct. This angle right here. Beautiful work. All right, we're supposed to find X and Y. Where is X in this picture? 3x minus 10. And it's on which side? It's representing the side length of AB. Segment AB, we said was congruent to which other segment? DE. They both have 2 congruence marks on them, at least the way I wrote mine. If 2 segments are congruent, then their measurements are equal. So the length of segment AB is equal to the length of segment DE. And how big did we say segment AB was again? 3x minus 10. How big is segment DE? 20. Now I need to solve this for x. So I'm going to add 10 to both sides. I get 3x equals 30. And then I divide both sides by 3, and I find out that x is how big? X is 10. Thank you. Now we need to find y. Where is y in the picture? Yep, it's above that letter C. It is angle BCA. Can I use the congruence again? Do I know an angle that is congruent to y and I know the measurement of it? No. So I'm going to have another way of finding this. How else can I find angles when I don't know them inside triangles? What'd you say? Look at the other side one. Well, I don't know how big this one is. I don't know how big this one is. I don't know how big this one is. Triangle sum theorem. Sorry, Angie. We're going to use our triangle sum theorem. What does the triangle sum theorem say? All the angles add up to 180 degrees. So I take y plus, what are the other 2 angles that we have there? 38 and what? And 90. So y degrees plus 38 degrees plus 90 degrees. This is all going to add up to give me 180 degrees. So I'm going to combine my like terms together of 38 and 90. What do I get when I add 38 and 90 together? 128. So y degrees plus 128 degrees equals 180. Subtract 128 degrees from both sides. And that means y is how big? 52, yes. So that angle in there would be 52 degrees, so y is 52. Nice work. Go ahead and flip over to page 299. Just the very next page, yes. We're going to learn about something called the third angles theorem and practice that a little bit before we go to your paper notes today. So page 299, the third angles theorem tells me that if I have two triangles and we have two angles in one triangle that are congruent to two angles in another triangle. So angle C is congruent to angle K. And then I have angle B is congruent to angle J down here. If I have two pairs of congruent angles, then that means that the third angle in each of those triangles has to be congruent. So angle A up here would have to be congruent to angle L down here. Because the measurement of angle A plus the measurement of angle B plus the measurement of angle C, all of those are going to add up to 180. If I look at the other triangle, my triangle sum theorem holds here as well. So the measurement of angle L plus the measurement of angle J plus the measurement of angle K, that would also have to add up to 180 degrees. Well, these two are the same. 180 is the same as 180. Angle C and angle K are congruent. We were given that in the picture, so that means they're the same. Angles B and J are congruent. We were given that in the picture, so their measurements are the same. If all of that stuff is the same, then that means that these two must be the same. Or else it would not, they both would not add up to 180 degrees. So far, so good? If I have two pairs of congruent angles in two triangles, then the third angle in each triangle would have to be congruent to each other. I would get that third pair. Let's look down at the example problem that has like that orange, almost kite-looking figure, and then it's got some triangles drawn on top of it. It says we're folding origami dragons for a party. And it tells me that the measurement of angle ABD, let's go find angle ABD. Start at A, go to B, and then down to D. That angle right there is congruent to angle CBD. So start at C, follow that to B, and then take it down to D. So those two angles right there that like come together to form the bottom tip of this, they are congruent to each other. In the picture, I can see two other angles that are the same size. What other two angles are the same size? Yep, angle ADB is a right angle, and angle CDB is also a right angle. They give me one other piece of information. They said that angle BAD is 58 degrees. Well, angle BAD, start at B, then come up to A, and then over to D. So this angle right here is 58 degrees. What other angle would have to be 58 degrees in that picture? BDF. Sorry, I didn't hear what you said. BDA. BCD. BDA is 90 degrees. BCD would be 58 degrees. This angle right here, because that would be the third angle in this triangle. We know the other two pairs of angles are congruent, so angle A has to be congruent to angle C. What do they want me to find in this problem now? Angle CBD, which is the one that I have outlined in this light blue color. So we're supposed to find this angle right here. How can I find that angle? How can I find angle CBD? Yes. Yep. What could I do to find angle BCD? Or CBD, sorry, I messed it up. What'd you say? Yes. We're going to use our triangle sum theorem. That angle that we're looking for, the measurement of angle CBD, gets added to my 90-degree angle up at the top. It also gets added to my 58-degree angle that we know because of our third angles theorem. Those have to add up to 180, so I can combine my like terms together, 90 and 58. What is 90 plus 58? 148. So the measure of angle CBD plus 148 degrees equals 180 degrees. I'm going to subtract 148 degrees from both sides. And so that means angle CBD is how big? .32 degrees. The book also doesn't have the 90-degree angle on the other side. So when you have a right triangle, if you add up the two angles that are not the right angle, those have to add to 90 because the whole triangle has to add up to 180. And if I know that one of those angles is 90, that means there's only 90 degrees left over to be split between the other two angles. Your book did it differently than me, but I wanted to practice with our triangle sum theorem again, so I did it differently than the book did. Go ahead and flip over to page 300. We're going to do one last problem here. We have a kite. First thing my eyes key in on is this right here. There's a right angle symbol. Angle ADB is forming a right angle. So what other angle would have to be a right angle if ADB is a right angle? CDB. So I'm going to go ahead and add that to my picture. I now know that those two angles are congruent. What other information does it give me about congruence? What other information did they give me in the problem? BCD, which is the same as BAD. So angle BAD would be this one right out here. This angle is 45 degrees. And they tell me that BCD, so B down to C and back over to D, this angle right over here is also 45 degrees. Do I have two pairs of congruent angles? Yes. So that means that these angles up at the top, ABD and CBD, would have to be congruent. They want me to find the measurement of angle ABD. So we are looking for this angle right here that I have outlined in orange. How can I find the measurement of angle ABD? What could I use to figure that out? Triangle sum theorem. The measurement that I'm looking for of angle ABD plus what? What are my other two angles that are inside that triangle? 45 degrees and 90 degrees. Thank you. Has to add up to 180. Combine my like terms together. What's 45 plus 90? 135. So the measurement of angle ABD plus 135 degrees is equal to 180 degrees. Subtract 135 degrees from both sides. And how big is angle ABD? 45 degrees. All right, we're going to switch over into your paper notes for just the last couple minutes here. So go ahead and grab your notes packet out. We're going to be down at the bottom of the page that we were working on yesterday. While you guys are pulling your notes out, can you tell me what is an isosceles triangle? Yes, an isosceles triangle has two congruent sides. So I'm going to draw a picture here. So there's my little example of an isosceles triangle. Two of the sides are congruent. My isosceles triangle theorem tells me if two sides of a triangle are congruent, then the angles opposite those sides are congruent. We have been using the isosceles triangle theorem without having an official name for it. Because when we talked about isosceles triangles, I told you if it has two congruent sides, then it has two congruent angles. So here's how I find the two angles that would have to be congruent. If this is one of my two congruent sides, I would go to the angle that is directly opposite that side. So this angle right down here, that would be one of my two congruent angles. And then if this is my other congruent side, I'm going to walk across the triangle to the side that is opposite that. That would be my other congruent angle. The isosceles triangle theorem converse. This is actually the one that we were using when I was asking you guys to classify triangles. The isosceles triangle theorem converse says if two angles of a triangle are congruent, then the sides opposite those angles are also congruent. Yep. Oh, yes, you can. Sorry. I thought you were asking if you left something in here. Yes, you can grab one of those yellow papers. You just can't write on it. It depends on how well you know the material. If two angles of a triangle are congruent, then the sides opposite those angles are congruent. So if I know that this down here is one of my two congruent angles, then that means that this would have to be one of my two congruent sides. If this is my other congruent angle, then this one up here would be my other congruent side. Real quick before the bell rings, I want to look at number 2. We're just going to talk about how we would set it up to solve it, but we're not actually going to solve it right now. We're supposed to find x and y here. Which one do you guys want to find first? X. Where is x in the picture? It's in the expressions for all three sides, right? Do we know anything about sides being congruent so that I could set some expressions equal? Not just do they look like they're the same size, do we know they're the same size? No. Remember, we can't go based on the picture because some people are really bad artists, including in your book. So we can't just go based on the way it looks. We have to know for sure. It would have to have congruence marks or they would have to tell us. Do we have a rule about what the sides in a triangle have to add up to? No. What has to add up to 180 in a triangle? What has to add up to 180? All of the angles in the triangle. So all of the corners, all of the degrees has to add up to 180. We don't have a rule about what the sides have to add up to. Because I could have a triangle that's itty bitty like this, or I could have a triangle that's huge. Those aren't going to have the same size sides when I add them up. But the angles will add up to 180. So can I find x first? We're going to have to find y first, and that's where we're going to pick up on Monday. I'll see you guys in class on Monday. Tuesday, we will have a Zoom. You do have to attend the Zoom. If you do not, you will be counted as absent for the class period. So please make sure you pop in. We're going to finish up talking about isosceles triangles on Monday. The homework that you just picked up on your way in is due on Wednesday. So on that Tuesday Zoom, I'm going to be going over homework stuff and helping you guys with it before it's due. So definitely make sure you come to the Zoom. Yes, Janaea. The teachers have an in-service day. So we're going to be doing professional development. In the morning, we'll be teaching remote learning. And then in the afternoon, we'll be doing professional development.